Okay, let's continue the lecture with finding the number of payments, or N, of an annuity. Now, during our previous discussion in the single amount, future value or present value of a single amount, okay, compounding, the period T in years can actually be calculated if we have the number for all the other variables, including the principal P, the future value amount, the interest rate, and also the frequency of compounding, which is our M in the formula. Now, for annuity, the number of periods and can actually also be calculated, but in this case, it is not that straightforward. Okay, we have to use this what we call the log algorithm. Okay, now don't be intimidated by the term log there, because it is actually our friend. Okay, we have learned it during our mathematics years in school. Now, recalling the future value annuity formula, which we have seen in the previous video. Okay, the future value of an annuity, okay, ordinary annuity in this case, equals to PMT and this term in bracket here. Okay, notice that to find the number of payments, which is our N, where is N? N is to the power of 1 plus I here, 1 plus I to the power of N. Okay. Now, since we want to find this N, let's put this term on the left-hand side, and this term we shift it, switch it to the right-hand side. Okay. So when FVA goes to the right, PMT stays. Okay. This term here move to the left, and at the end, you leave this 1 plus I to the power of N alone here. Okay. The N, it becomes 1 plus I to the power of N. Look at this fourth line here, equals to this term, which is your future value of an annuity, divided by the PMT, multiplied by I, all together in bracket, and then plus 1. Now, at this stage, at this point of time, in order to solve for N, what you need to do is, similar to what we have seen earlier, you log both terms, the left and the right hand side, both terms. So when you log it, if you can still recall from the previous lecture, the reason we log it is because only by logging it that we can take down the N term, which was previously, okay, to the power of, okay, which is quite difficult to solve. Okay, but now when it comes down, same level as the other terms, we can solve it using arithmetic. Okay? So leaving N alone on the left-hand side, that gives us N equals to, okay, the log of FVA divided by your PMT minus times I, okay, plus 1, divided by log of 1 plus I. Okay? So that is our point. That is our objective actually, to solve for N. Okay? And N is in terms of equals to, okay, the interaction of the other variables here. Okay. Now, you don't have to worry about the, so-called complexity of the formula above, because the chances are you don't actually have to memorize it. So what you need to do is, using the basic formula, which will be given to you anyways, okay, at the back of the exam papers. So you just arrange the information given accordingly. So make sure that if it is a future value, okay, you plug it in the formula as a future value of an annuity. Okay, make sure it is the correct I. Make sure you know the frequency of compounding in a year, your M. Okay, so when you put everything in its place, and then logically you move forward line by line, okay, using the algebra operations that we have seen just now. Okay, let's look at an example, okay, to make it clearer. Okay. Now you need to accumulate $10,000 to buy a motorcycle. Now, if you can afford to save $200 per month, it in a bank which pays interest of 6% compounded monthly, how long will it take until you can afford to buy the motorcycle? Okay. First and foremost, okay, you need to be clear. Okay, by reading this question, you need to know the objective. What do you need to find? Okay, where is the keyword? How long will it take? Okay, so you know now for sure that your answer will be in years because it asks you how long will it take. Okay, that is number one. Number two, which particular formula to apply? Is it future value or is it present value? Okay, where is the keyword? Here, you need to accumulate, right? So you need to accumulate means starting now, okay, the action that you need to do is you need to put some money, okay, right? So that at the end of the day, you will have $10,000. All right. So this case, number two, you know that, oh, this is the future value. You need to apply the future value formula. And thirdly, is it a single amount or an annuity? Okay, where is the clue? The clue here is in this per month. If you can afford to save $200 per month, so this is the clue for you, cue for you to know that this is an annuity. So it is a future value annuity, and you need to solve for n. And this becomes easy for you because you know since this is per month, so this is a monthly compounding. So m equals to 12. Your j is 6%, so you know that your I is j divided by m, so 6% need to be divided by 12 first, and your t is n is to be solved at the end, okay, of the problem. So put everything in its place, the proper place. The future value of an annuity is the $10,000 because this is the amount that you need to accumulate. Okay, the figure in the future, hence the future value, equals to PMT is the amount that you need to put in the bank every month, the $200. So this is your PMT. Your J is 6%, and since your M is 12, right? So you need to divide by 12 to the power of n. It is still n because you need to solve for this n minus 1 and divided by your I, which is 6% divided by 12. So you put, you write this down first in this, the first line, right? And as previously shown, you transfer this term to the left-hand side and this term to the right-hand side. So what happened is that this when 10,000 moves to the right, it becomes 10,000 divided by 200 equals to 50. And 0.06 divided by 12 is actually 0.005. Okay, so 1.005 to the power of n minus 1 divided by 0.05 equals to 50. So at this point, this 0.05 need to be transferred to the right, so it will be multiplied by 50 to become 0.25. So leaving you 1.005 to the power of n minus 1 equals to 0.25. Finally, this minus 1 transferred to the right hand side, it becomes 1 plus 0.25, hence 1.25. Then only you log both terms in the left and the right hand side. By logging it, right, n comes down to become n log 1.005 equals to log 1.25, and leaving n alone, okay, in the left hand side, so it becomes n equals to log 1.25 divided by log 1.005. Okay, so you during my time I have to use a logbook, so it was quite tedious. Okay, so now you have a scientific calculator, so easily you can solve this. It's just that you need to know which button to press, okay, in order to find this log 1.005 and log 1.25. Once you know it, easily you can solve for n, which is 44.7. Is this the answer just yet? No. Okay, not yet. You need one more operation because why? You know that N equals to T times M. What is our question? How long will it take? Means that your answer has to be in years. So you are actually solving for T. You need to find your T. So since N equals to T times M, therefore T equals to N divided by M. So your M is 12. So your T is equals to 44.7 here, which is your N. Divide by 12 equals to 3.73 years. So with this scenario, being able to put aside your salary of $200 per month, okay, in a bank that pays 6% per year compounded monthly, it will be you need to save for 3.73 years, right, to be able to afford to buy this $10,000 motorcycle in cash, okay, without using a loan. But you need to wait 3.73 years. Okay. All right, that's it for finding the number of payments. So I will see you in the next video, okay, in another subtopic.